This lecture would be on performance testing of boilers, a very relevant subject for those who do energy audit in the industry. Uh, the reason being, boilers, or as they are known as steam generators, they are energy guzzling equipments in the sense that they consume oil or gas or some solid fuel like coal or biomass. So this boilers or steam generators are seen in process industries, and they do contribute a lot to the energy bill of the industry. So as an energy auditor or as an engineer who is responsible for saving energy in the industry, this should be the place where one should look at to intervene. So this lecture would be on the methods or the techniques or the tricks to save, and before saving actually to measure and then save energy in the boilers. So I have titled it as energy efficiency of boilers, and I hope that you would really enjoy this. So what exactly is this energy efficiency in the boilers? We would be seeing in the series of lecture videos. Boiler efficiency, uh, when you say boiler efficiency, there when you buy a boiler, there would be a term called as boiler efficiency in the specification sheet. So this boiler efficiency would capture basically about the performance of the boilers, performance in the sense that what is the combustion efficiency, whether the combustion is good or poor, how is the heat transfer, whether the heat transfer is proper or there are scale formation on the boilers, and how is the boiler operated and maintained. So all these parameters like poor combustion, heat transfer fouling, and poor operation and maintenance would reflect in the lower values of boiler efficiency. So we need to have some method to see whether the boiler has really degraded or not. And there are two methods which are widely used in the industry by the auditors to monitor the boiler efficiency. One is called as the direct method, and the other is called as the indirect method. Now, by the term direct, what we mean is that we basically compare the energy content of the boiler with the energy gain of the working fluid. So direct method directly gives us the boiler efficiency, and by direct method what we do is that we compare the output of the boiler with the input of the boiler. Very simple method it is. In the indirect method, it is the purpose is to obtain the boiler efficiency between by measuring the losses which happen in the boiler. What we do is that we just calculate the losses taking place at different parts of the boiler, and then we sum up those. So that summation of the losses we subtract it from the energy input. So these two methods, that is determination of boiler efficiency by the direct method as well as indirect methods, these are widely used in the industry, and both have advantages and disadvantages, which would be shortly discussing. Now, before going to the efficiency testing, we need to understand that the efficiency testing helps us to find out how far the boiler efficiency drifts away from the best efficiency. So best efficiency values of the boilers, they are provided by the boiler manufacturer. And when you arrive at the efficiency values by either of this method, that is by the direct method or the indirect method, it helps us to compare and find out whether the boiler efficiency presently is away from the best efficiency or it is closer to the best efficiency. Obviously, if the value which we get from these two methods, if it is closer to the best efficiency, we need not worry. But if it is farther from the best efficiency value, then we need to look for the measures of improving the boiler efficiency, and then that becomes the most important part for the energy auditor. So what we would be learning now is how do we compute this boiler efficiency by both this method. As I said, direct method and indirect method, all these methods, they are actually using some standards. Okay, we have some standards for boiler testing, and those standards are given here on this slide. So you see that uh, there's a very standard procedure for obtaining the boiler efficiency, and we can use certain standards which are followed by different nations. For example, there are British standards BS 845 1987, or there are in India, for example, there are Indian standards for boiler testing, which is IS 8753. So different countries would have different standards for boiler efficiency testing, and what they give you is the spot measurement of boiler efficiency. So this has to be clearly understood, that the efficiency value which you would be obtaining by using the standards, by using these methods, that would give you the spot measurement of boiler efficiency. And once you get this spot measurement of boiler efficiency, we can do this kind of testing for throughout the day, for different days of the year. And then we can, if we observe some abnormal deviations, then we need to investigate those deviations. We need to pinpoint the problem area for necessary corrective action. So, as I said, the boiler efficiency test give us the current level of efficiency for performance evaluation, and which is obviously a prerequisite for energy conservation action in industry. So, what is a what? How do you define the boiler efficiency? Uh, in the direct method, as I said, it is basically the ratio of boiler output to the boiler input. Now, what is the boiler output? So, boiler output and boiler input has to be understood in terms of heat output and heat input. When you say heat output, we see that the heat output of the boiler is basically the heat which is heat transfer which has happened to the water as it gets converted to steam. So when we talk about the output of the boiler, we need to measure the initial energy of the water, which is nothing but the feed water enthalpy. And we need to then find out what has happened to that energy. Well, obviously it has increased, and that would be the steam enthalpy. So the steam which is generated by the boiler, we need to know its energy content. That is the steam enthalpy we need to obtain. And this change, that is the increase in the enthalpy of the feed water as it gets converted to steam, this change in the enthalpy, that is steam enthalpy minus feed water enthalpy, has to be multiplied by the steam generation rate of the boiler to obtain the boiler output. So the numerator in this term which you see over here, that is the steam flow rate into the difference between the enthalpies, the heat content, would give you the boiler output. So note that when you say boiler output, we are talking about the energy output. So we should not say that boiler output is steam. We should say that the boiler output is a thermal output, which is the steam flow rate into the enthalpy difference between the steam and the feed water. Then what is the input? Obviously, when you talk about boiler, the input is the energy which we are providing because of the combustion of the fuel. So when you are burning the fuel, because of the calorific value of the fuel, the energy would be released. So calorific value is what? Calorific value is the heat content of the fuel. It could be expressed in kilocalories per kg if it is a MKS units, or in the SI system, we denote it by kilojoules per kg or megajoules per kg. So the gross calorific value of the fuel has to be obtained, and then that gross calorific value has to be multiplied by the actual fuel which is input to the boiler. So if we know the fuel firing rate, that is actual fuel which is input to the boiler, and we multiply it with the gross calorific value, that gives us the input to the boiler. So the input is obtained and the output is obtained, and the ratio of output to the input is the direct method of boiler efficiency. So this is how we get this is the expression for obtaining the direct method of boiler efficiency. Now, how do we measure those things? Okay, in order to measure this fuel consumption or the fuel input, it would depend upon the type of the fuel. So if it is gaseous fuel, then we need to go for the gas meter. Obviously, the gas meter has to be the approved type. It has to be calibrated properly, and the measured volume which the gas meter would give you in liters per hour or whatever, or meter cube per hour. So that measured volume has to be corrected for temperature and pressure. This we need to note down. Okay, so the gas meter would give you the fuel consumption value for the gaseous fuel, and it has to be converted to appropriate mass. This volume has to be converted to appropriate mass. So that becomes the denominator of the expression in the boiler efficiency if it is a gaseous fuel. If it is a liquid fuel again, then we need to take care of the viscosity of the liquid and accordingly choose the correct meter, correctly calibrated meter for monitoring the fuel consumption. Okay. One can also go for, if the meters are not available, especially if the calibrated meters or we are not sure about the calibration, then one can actually do the calibration of the day tank, the fuel tank, which is there in the industry, and one can measure how much. You can just put a scale over there and one can measure how much is the actual consumption throughout the day, or the time period for which you are chosen for the experiment, and that gives you the fuel consumption. And for the solid fuels, obviously it is difficult to get you the value, but one can weigh. One can have a reasonably accurate weighing machine. You can load that. For example, if it is a wood fired boiler, you can weigh the wood initially and then load it in the boiler and then note down the time which is required for consumption of this wood. The consumption, I mean the combustion phenomena of this wood. Okay. There are modern techniques also wherein the hoppers are the place from which the fuel is fed to the boiler. So the hoppers over the boilers, they have a calibrated load cells, and that gives you a reasonably accurate fuel consumption. So as I said, the denominator of the expression which you talk about, this fuel firing rate, this can be easily measured depending upon the type of the fuel used. If it is a gaseous fuel, as I said, we would go for the gas flow meter. If it is a liquid fuel like LDO, light diesel oil, or furnace oil, it could be liquid flow meter. And for the solid fuels, one can use a weighing scale or the calibrated load scale on the hopper. Now, if you want to measure the steam flow rate, because the numerator has a steam flow rate. So there are modern flow meters of the variable orifice type, or again vortex shading types flow meters are available. A lot of flow meters, if you go do a Google search, you will find the modern flow meters which are there in the market. So one can choose for a proper calibrated steam flow meter. In many cases, you will find that the steam flow meter is in the place, but if it is not there, then one can install it in line and get the steam flow rate. Other simple method of finding the steam flow rate is just to monitor the feed water measurement. Okay, because you know that in the boiler, whatever is the feed water provided, that gets converted to steam. So by the mass balance, whatever feed water is being supplied, that becomes steam. So if you measure the feed water flow rate, that becomes the steam flow rate. So this is how one gets the steam flow rate. So now, in order to obtain the boiler efficiency, we have seen how do you get the fuel firing rate, how do you get the steam flow rate. Gross calorific value can be obtained by doing the fuel testing in the bomb calorimeter if it is a solid fuel or liquid fuel, or in the gas calorimeter if it is a gaseous fuel. Uh, uh, One can also use the data which the fuel supplier would provide us to use this gross calorific value in the calculations. In the numerator, you see that there is a term called as steam enthalpy and feed water enthalpy. So I had actually explained you in some other video how to calculate the enthalpy. What is enthalpy? This things require an understanding of properties of steam. Properties of steam video you should see if you are not clear on this. Okay, so the steam enthalpy, if you want to find, you need to obtain it from the steam table by knowing the pressure of the steam and temperature of the steam. So in the boiler setup, there is a pressure gauge which can read the pressure, and there is a temperature indicator which is connected to the thermocouple which would read out the temperature. So it is pretty easy to note down the pressure from the boiler setup and the temperature on the boiler setup, and that helps us from the steam tables, from the properties of the steam, to obtain the steam enthalpy. In order to get the feed water enthalpy, again we need to note down the temperature of the water, and with the knowing the temperature of this feed water, we can calculate the feed water enthalpy from the steam tables, from the properties of steam. So this way one can measure the boiler efficiency by the direct method with a very few number of readings. So which few number of readings we are talking about? We talk about measuring the steam flow rate, we talk about measuring the fuel firing rate, and we talk about measuring the pressure and temperature of the steam and the temperature of the feed water. So only these few readings help us to get the boiler efficiency, and this is the advantage of doing the boiler efficiency test by the direct method. Okay, so as I said, this is the most important advantage, that we can conduct the boiler efficiency with a limited number of readings. However, this method is not recommended when you are talking about doing an energy audit of the boiler, because this method does not tell you as to why a particular efficiency is obtained. Means, for example, if the boiler rated efficiency is 90%, and by using the direct method you obtain a value of 80%, the actual boiler efficiency, you get it by using this direct method. If it is 80%, then what at the most you know is that the boiler is not operating properly. But why? What explains this 10% loss? That we cannot tell from the direct method calculation. So direct method does not give you any clue why the efficiency is low, where the losses are happening, and hence it gives us limited tool to intervene, because our job is basically to save energy in the boiler, and for saving energy we must know where the losses are happening. This, however, is not provided by the direct method calculation. The other problem with the direct method is that it is inaccurate. Means, if you make error in the measurement of fuel consumption or in the measurement of steam flow rate, then that would bring in large errors in the value of the boiler efficiency. So that way it is very sensitive to the error which normally operators would, or the auditors would have when you do the measurement. So measurement errors would magnify in this direct method boiler efficiency calculation. So it is not recommended, especially when you have a large process industry, and we are given the task of saving energy in that boilers. We need to go for the other method, which is called as the indirect method or heat loss method, which we will be discussing in the next class. Thank you very much. Bye for now.